Okay, so here we are, question 20. So this is a tech-free question. So at the end of the first stage of the growth cycle, a species of a tree has a height of 5 meters. Height equals 5 meters, and the trunk has a radius of 15 centimeters. We're going to call that when t is equal to 0. So in the second stage of its growth cycle, the tree stays at the height of 5 meters. Height equals 5 meters, and the radius has a growth rate that follows this equation. So your radius, we're not really sure of your radius yet, but we do know it's after 10 years. Now, this equation is in centimetres per year. This is in centimetres per year. And I can see down here that this is also in centimetres. So I'm going to change this height to be 500 centimetres instead of using the metres. Okay, so this doesn't tell me the radius. This tells me the growth rate, which means that if we're looking at growth rate, it's the derivative of our radius function. So first thing we're going to do is we're going to integrate this function. Which means I'm integrating 1.5 plus sine pi t on 5 with respect to t. When I integrate that, I'm going to end up with 1.5t. This part of the function is going to become sine would go to minus cos, so minus cos, bracket doesn't change, plus c goes on the end. Now when I take the derivative of this function, I'll end up with pi on 5, so it becomes 1 over pi on 5, which will convert to 5 on pi like that. So that's the function we've currently got. Now we do have some other information here that we can use to help us solve for c to finish off this equation for the radius. Okay, so I know these two facts, so I'm going to use them to solve for c. So we're going to let the radius equal 15, the time equals 0, and we're going to solve. So 15 equals 1.5 times 0, so that'll just disappear. 5 over pi cos, pi times 0 over 5 plus c. So this part here on the end, that's going to be when cos is at 0. When cos is at 0, it's equal to 1. So now all I'm left with is 15 is equal to minus 5 on pi plus c. I'm going to move this to the other side, which will give me that c is equal to 15 plus 5 on pi. Okay, so now I can complete the equation. So therefore, the radius is going to be given by 1.5t minus 5 on pi cos pi t on 5 plus 15 plus 5 on pi. Okay, so now I've got an equation for the radius. I've got a time. I can just chuck it in and I can work out what the time was at that point. So now we're going to let t equal 10. So 1.5 times 10 will make 15 minus 5 on pi. When I substitute 10 in here, it'll become cos of 2 pi, which is also going to be 1. So that'll just end up minusing 5 pi plus 15 plus 5 on pi. So that is going to give me a radius of 30. Okay, so now I've got the radius at the end of the growth cycle. I've got the radius at the start of the growth cycle. We can chuck it into our formula for volume and work it out. So I'm just going to start by stating the important information just so you can see what I'm using. So end of second cycle. Radius equals 30, height equals 500, and end of first cycle, radius equals 15, and the height equals 500. I'm just going to quickly scroll up and double check because it would suck if I kept going and that was wrong. Okay, we're good to go. Okay, so second cycle. So our volume is equal to, now it's a cylinder, so it's going to be pi r squared times the height. So that's going to be pi times 30 squared times 500. So pi of 900 times 500. Now that's going to collect all the zeros up. So 1, 2, 3, 4 zeros, and 9 times 5 will make 45. So it's that pi. Let's do it for the first cycle. So volume equals pi r squared times the height. So that's going to be pi times 15 squared times 500. Okay, so that's going to be pi times 225 times 500. So now I'm just going to do a little sum to the side here to work it out. So this times this, everything's going to be 0. Next column starts with a 0. Everything's going to be 0. Next column starts with a 0. And so 5 times this is going to be 25. This times this will make 10 plus the 2 will make 12. 5 times 2 will make 10 plus the 1 will make 11. So that's the number that we're looking for here. So 1, 1, 2, 5, 1, 2, 3, and that's pi. Now, in the question, let's just go back up and read it because I know there's a trick somewhere. So determine the ratio of the trunk's mass at the end of the second stage to its mass at the end of the first stage. So it wants a ratio. Here's our ratio. It's going to be 4,500 pi is to 1125000 pi. And looking at that, I think I've got too many zeros. Let's double check again. This one times that one, that's going to all be zeroed out. Next one starts with that. It's going to get zeroed out. The next one, yeah, I've got one too many zeros there. Just double check on my classic Casio. So 225 times 500. Yep, that's better. Okay, so I know because of the style of question this is, because it's in the tech-free section, that you're going to probably end up with nice numbers. So I'm first just going to check and see what happens if I multiply this one by 2. So if I multiply that by 2, I'll end up with that number. And if I multiply that by 2, I'll end up with that number. So that is 4 times larger. Maybe this one's missing a 0. It sure is. This one should have, wait a minute, 3, 4 zeros. 2 commas in. Sometimes that makes it easier to see. So this one here had too many zeros. Times it by 2. Yeah, look, it's 4 times larger. You figure that one out yourselves. All right, so that's your final ratio when you work it out. Ta-da!